All right, in this video I'll be discussing how to factor trinomials of the form ax squared plus bx plus c. In other words, they're quadratic. You're going to have an x squared term, an x term, and a constant. And we're going to use what's called the AC method. So before I get started, and I'm just going to show you how to do it. Normally after you do about 2 or 3 problems, students start getting it. It may take a little more than that, just kind of depends. But I want to look at something here, because basically I'm giving you a trinomial and I'm asking you to factor it or write it as a product. So in the past what we've done is we had to multiply a binomial times a binomial, and we would FOIL. We'd multiply the first terms, I get the x squared. The outer terms, I get 3x. The inner terms, I get 2x. And the last terms, I get 6. And then these are like terms, and we get x squared plus 5x plus 6. But what if we're trying to go in reverse and take this and factor so that we get what we started with? Well, you can see that the x times the x give us the x squared, so that's the easy part. Now, where did the 6 come from? Notice it was the last 2 numbers multiplied. And then where did the 5 come from? Well, notice we added 2 and 3, so that actually is these numbers. And so these 2 numbers here need to add to 5. So they multiply to 6, and the numbers need to add to 5. And so we would get x plus 2 times x plus 3. So it seems like, this isn't so bad, but if you look at this problem here, notice the only thing I changed was I put a 2 in front of this x. So your first product is 2x squared, your outer product is 3x, your inner product 4x, and your last product is 6. And then you add these 2 terms and you get 7x. Well, notice if we're trying to reverse this, we still have the product of these first terms gives us the 2x squared. So whatever's here and here will multiply to that. Now we do have the issue where order is important, because do I put the x here or the 2x here, and vice versa. But the main thing is these 2 numbers multiply to 2x squared. What about the 6? Well, just like in the previous problem, notice the 2 times the 3 give us the 6. What you're going to see that's different, though, is 2 plus 3 is not 7. So in fact, what we did over here doesn't actually work in this case. Any case where we don't have just x and x. In this case, we have a 2x. So some number other than 1. So basically here, our x squared term had a coefficient of 1. In this situation, these numbers will multiply to the 6 here and add to the 5. But in this case, because this is not a 1, that's not going to be true. So anyway, we would have the 2x and the x. Where do we get the 7x here? Well, notice that was 3x plus 4x. It turns out there is a pattern here, but it's not obvious at first glance. But notice my a and my c here. Remember, it's ax squared plus bx plus c. In this case, ac is 12. Notice that the 3 and the 4 here, which is what we're trying to find, those numbers multiply to 12, and they also add to 7. And so this is how we're going to factor a trinomial like this. Basically what we're going to do is we're going to take 3 terms and we're going to write it using 4 terms, and once we do that we can factor by grouping. So that's our basic strategy, and that's why we're doing it. Let's go ahead and get started. Alright, so on the first one here, and by the way, there's many ways you can learn to factor a trinomial. Factoring using trial and error is one of the most common. In fact, that's the way they used to teach it most of the time. But it's, as far as, I'll just put it this way, the easiest way to learn this is to use or what I've found to be the easiest is the AC method, because you treat a problem like this or like this the same. It doesn't matter if your number or coefficient out front is 1 or not. You're going to use the exact same approach. In the old days when we did trial and error, and some of you may do that, you have to treat those two problems differently. So this has been the method that I found the most successful for the majority of students, and so that's why I use it. All right, so here we're trying to factor this, and actually, I'm getting ahead of myself here. So we're trying to split this into 4 terms. We got to figure out what to split the 8x into. So basically, I'm going to go ahead and do this. I have AC and B. In this case, my AC would be 1 times 12. Remember, this is my A and my C here. So 1 times 12, that's AC, which is 12. And our B term is 8. So we need two numbers that multiply to 12 and add to 8. Well, you can actually write out all the possibilities. 1 times 12, 2 times 6, 3 times 4. Those are all the ways you can multiply numbers to get 12. Now the ones that add up to 8 are the 2 and the 6. There's only going to be one combination that works, and that's how it always is. So let's go ahead and split our B term. We're going to rewrite the x squared, and we're using these numbers here to break the 8x into 2 terms. So we're going to use 2x and 6x, and then we'll bring the 12 down. So the x squared just comes down, the 12 comes down, and we're splitting this middle term. So sometimes I've heard this called the split B method, because we're going to split our B basically. Remember, B is the coefficient of x. And so now we can factor by grouping. We can factor out an x. We get x times x plus 2. And then when we factor by grouping here, it's going to be 6 times x plus 2. And I need a plus in between. Notice if you multiply here, this is equal to that. If you multiply here, this is equal to that. So now we have 2 terms with a common factor of x plus 2. And you can see the other factor will be x plus 6. So I am assuming that you know how to factor by grouping in this video. That's what we did before we did this, or before we got here. Okay, so number 2. So if you think you got it, you might try number 2, or then watch the video, or you can just watch me do another one before you try one yourself. So again, I need to find AC and B. So 1 times 15, that's my AC, 15, and B here is negative 8. It's important that you use the sign of that B term. All right, so let's see, factors of 15 would be 1 and 15, 3 and 5. Now notice here, I need 2 numbers that multiply to 15, so they could both be positive or they could both be negative. Since they add up to a negative number, they must both be negative. So this really is the key step. You want to make sure you have the right numbers. Negative 3 times negative 5 does equal 15. And negative 3 plus negative 5 is negative 8. So let's go ahead and split our B term. It'll be a minus 3x and a minus 5x and plus 15. Now sometimes students will ask me, does it matter which of these numbers go first? And the answer is it doesn't matter. Your work will look a little different because the order is different here, and it's going to change some things. But your final answer will be the same. So it doesn't really matter which of these comes first, the minus 3x or the minus 5x. So let's factor by grouping. We get x times x minus 3. And then, we know that we expect to get another x minus 3 here, because if these aren't the same, we wouldn't be able to factor by grouping. So that means to get these 2 terms, I need to multiply by a negative 5. Notice negative 5 times x is a minus 5x, and negative 5 times negative 3 is 15. And so we have 2 terms with the common factor of x minus 3, and the other factor is x minus 5. The other thing I would point out is we could always FOIL this at the end, and we should get what we started with. You can check yourself quite easily. All right, so notice this time this is not a 1x squared, but it won't matter. We're going to use the exact same method. So I'm writing A, C, and B. This is probably the last time I'll do that, just to help you in the beginning to know where those numbers are coming from. Normally I just write the little chart. All right, so in this case, A times C, that's going to be 14, and our B is 9. So we need two numbers that multiply to 14 and add up to 9. Now, so far I've been showing you all the possibilities, but just keep in mind that as soon as you see the numbers that work, you don't really need to go through all the other possibilities. And in this case, there's actually only two, but 2 and 7 are the ones that are going to work. I'll go ahead and write down the other factors, 1 and 14, but you can see that the 2 and the 7 are the ones that work, and as soon as you see the combination that works, you don't really need to worry about the other possibilities. But if you need to go through all the possibilities, you can be very systematic when you do this procedure. All right, so let's split our b term. We're going to get 2x squared plus 2x plus 7x plus 7. And again, the order of these two terms is not important. You should end up with the same answer no matter which order you use. Now be careful here. You can see the GCF here is actually 2x. It'll be times x plus 1. And so when I factor here, I'm expecting to get an x plus 1. And I need to multiply by 7, and it'd be positive 7. Notice when you multiply here, you do get what we have here. So here's my two factors, or two terms. A common factor is x plus 1, and the other one is 2x plus 7. All right. So hopefully by now you're starting to feel like you've got this. If you understand the technique, you should be able to do all the problems on this page up through number 9. So I would encourage you to do that, and then you can look at the solutions. Or if you feel like you need to see some more examples, keep watching. Otherwise, you're just checking your answers. Okay, so let's see. On number 4, our AC here is negative 30. And our B, now we know that's a 1y. We don't write the 1, but it is a 1. Now I can look at this, and I know that 5 and 6 are the numbers that are going to work. And you just got to get your signs figured out. But again, you can be very systematic. I'm going to write out all the factors of 30, 1 and 30, 2 and 15, 3 and 10, and 5 and 6. You'll notice I like to write my smallest number first and my largest number second. It just helps when you're consistent. It makes things a little bit easier. So remember now, these two numbers need to multiply to negative 30. So it's really important that you're getting your signs correct when you find your AC. We're multiplying 3 times negative 10 here. So I need two numbers that multiply to negative 30 that add to 1. Since they add to a positive number, and since they multiply to a negative, I know they're going to be opposite in sign. But because they add to a positive number, I want to make the bigger ones positive and the smaller ones negative. So notice the negative 5 and the 6 are going to work because they multiply to negative 30 and they add to 1. And again, this is a really important step. This is literally the key step. You've got to make sure your numbers work. And so now we can plug them in. We got 3y squared minus 5y plus 6y minus 10. So here the only thing you can factor out is a y. It'll be y times 3y minus 5. And I'm expecting a 3y minus 5 here. And I need to multiply by positive 2. Notice 2 times 3y is 6y. And 2 times negative 5 is the negative 10. So for these two terms, I have a common factor of 3y minus 5, and you can see the other factor is the y plus 2. All right, let's go ahead and do this one here. So we need two numbers that multiply to negative 16 and add up to 15. Let's see. So the factors of 16 are 1 and 16. Whoops, 2 and 8. And 4 and 4. Now, as soon as you add the 1 and 16, you actually have the right numbers. Now remember, just like in the last problem, these two numbers multiply to a negative, so one of them is positive and one of them is negative. Since they add to a positive 15, I need my smaller numbers to be the negative ones. And you can see negative 1 plus 16 is the 15. So we're going to have x squared minus x plus 16x minus 16. So here when I factor, I can factor out an x times x minus 1. So here I know that I'm expecting an x minus 1 when I factor, and that would make the middle term positive 16. 16 times x is the 16x, and 16 times a minus 1 is negative 16. So here we have a common factor of x minus 1. And if you cross those out, you can see the x plus 16. And as I stated before, you could always FOIL this out to double check yourself, and you should get what we started with. All right, let's move on to number 6. So 5 times negative 4, that's my AC, negative 20. And our B term is negative 8. And I'm not going to write out all the factors the way I have been just to save some time. You should find that 2 and 10 are the ones that work. And again, they multiply to a negative, so one of these is positive and one of them is negative. Because they need to add up to a negative, we're going to make the bigger one negative. Notice 2 plus negative 10 is going to work. So when you multiply, you do get negative 20. And when you add, you do get negative 8. So we can break this into 5x squared plus 2x minus 10x minus 4. So for the first two terms, we can factor out an x. X times 5x would give me the 5x squared, and x times 2 would give me the 2x. So here I would get, I'm expecting a 5x plus 2. And to get the minus 10x here, I need to have a multiply by a minus 2 there. Notice negative 2 times 5x is negative 10x, and negative 2 times 2 is a minus 4, so we're good. So our common factor is 5x plus 2, and it'll be times x minus 2. Now I just want to remind you that if you're having problems getting the same thing in both of your parentheses, that tells you that you've made a mistake somewhere. Maybe you picked the wrong numbers back here, or maybe your AC is wrong. Sometimes students make this a positive 20. They don't include that negative on the 4. So anytime you're not getting the same thing in the parentheses, that's telling you that something's wrong, and you got to figure out what you did. The other thing I would say is hopefully by now you feel like you've got the technique down. All I'm doing at this point is just giving you an opportunity to practice so you get good at this technique. Let's move on. I'm going to go ahead and do the last 3 here. I'll probably go pretty quick just because I'm assuming at this point you're just checking your answers mainly. Still using the same process. Now this problem looks a lot like x squared minus 2x minus 8. The difference is this y and the y squared. It turns out this problem has the same, this trinomial has the same form as the ones we did up above. It's just we've got those extra y variables. But it turns out it's the same. I mean, look at our x squared and then the x term. It's just our constant term has a variable in it, or what's usually our constant term. But we're going to do the same thing we've done before. AC here is 1 times negative 8, which is negative 8. And our B term is negative 2. And so 2 and 4 are going to be the numbers that work here. And again, they're opposite in sign because they multiply to a negative 8. Since they add to negative 2, I want to make the bigger number negative. Notice when you multiply negative, or 2 times negative 4, you do get negative 8. And when you add, you do get negative 2. So the only thing that's going to be different here, other than just recognizing it's the same form as the other ones, or very similar, is when we split our b term, we're not going to have x terms, we're going to have 2xy terms. So it'll be plus 2xy minus 4xy minus 8y squared. And so now let's factor by grouping, just as we always do. Notice we have a common factor of x times x plus 2y. So when I factor here, I'm expecting an x plus 2y. So what times x will give me negative 4xy? I need a minus and a 4y. Notice negative 4y times x does give you negative 4xy, and negative 4y times 2y does give you negative 8y squared. So for these two terms, we have a common factor of x plus 2y. And when you cross that out, you can see your other factor is going to be x minus 4y. All right, let's look at this one here. I probably should have mentioned each one of these problems at the end here has a little different twist, something a little different about it. Although actually not so much here. There's another point I have to doing this one. 3 times 20 is 60, and your b term is negative 17. And you may have found this one's a little harder. It's not that the problem's any different, it's just that you're dealing with a bigger number which has a lot of factors. So again, you can be very systematic. We know 1 times 60 is going to work. You should try 2. 2 times 30 works. Could always divide, well, because it's an even number, we know it's divisible by 2. If you divide by 3, we know 3 goes into 60. 3 times 20. Of course, you could always divide your 60 by 3 on your calculator to check. So does 4 work? Well, if you divide 60 by 4, you find that you get 15. So 4 times 15 is 60. Does 5 work? Yeah, it ends in 0, so you can divide 60 by 5 and you find that's actually 12. Of course, 6 works. 6 times 10 is 60. And, you know, the question is, how far do I have to go? I've checked 1 through 6. If I check 7, that doesn't work. Turns out I need to check 2 more problems here. 7 doesn't go into 60. You can do the division if you want. 8, if you divide 60 by 8, that doesn't work either. But it turns out that you can stop right here. How do I know that I can stop at 8? Well, there's a little trick that you can use. Notice 7, if you square it, is 49. And 49 is not bigger than 60, and so you have to keep going. However, 8 squared is 64, which is bigger than 60, and so that tells me we can stop. So in other words, as I check for bigger factors, I would find that they always pair up with the smaller factors. So that's the basic idea, but we can stop. As we check these numbers, we've gone 1 through 8. As soon as we get a number that you square and you get a bigger number than this number here, the 60 here, that tells you that you've checked all the possibilities. All right, so we know these two numbers multiply to 60 and they add to negative 17. Well, they're both positive or both negative since they multiply to a positive 60. Since they add up to a negative, they have to both be negative. I'm just making all my signs negative. So we're looking for the 2 that add up to negative 17. That would be negative 5 and negative 12. And so those are the numbers that work. Numbers that multiply to 60 and add to negative 16 or 17. So let's split our b term. We're going to get 3x squared minus 5x minus 12x plus 20. So we can factor out at x here. It'll be x times 3x minus 5. I'm expecting a 3x minus 5 when I factor these last two terms. And notice 3x times a minus 4 would give us that minus 12x. And negative 4 times negative 5 does give you 20. And so our two terms have a common factor of 3x minus 5. And when you cross these off, you can see x minus 4 is your other factor there. All right, we got one more, and I think I'm going to stop this video and I'll do a second one. So here I need two numbers that multiply to negative 12 and add up to 5. Well, if you look at the factors of 12, you got 1 and 12, 2 and 6, and 3 and 4. Now, since these numbers multiply to a negative, I know they have opposite signs. Since they add to a positive, I need to make the smaller ones negative. The problem is none of these add up to 5. And so in this case, this doesn't factor. We either call it prime, or I think our book is saying not factorable. So there's no guarantee that you can always factor a trinomial. Most of the ones I give you are going to factor, but if you run into a problem like this, we say that it's prime or we say it's not factorable. All right, so let's go ahead and stop right there.